10.5, the binomial theorem. So today we're looking at Pascal's triangle, and I really hope you remember this from an earlier math class. So my 0 row is just the number 1. My first row is the number 1, 1. And then each row after that, we're starting them with 1s. And then you can kind of see from these blue triangles here that this number below it, 3, is the sum of the 2 that are up above. 2 plus 1 equals 3, and so I have a 3 below that. So the row starts with a 1, and then I get those other numbers in my row by adding the terms up above. And so I get the 1, 3, 3, 1. And the next row, the 4 is the sum of 1 and 3. 6 is 3 plus 3, and so on and so forth. So when I create it myself, it's pretty easy. I just know I start out with a 1, and then my second row is 1, 1, and then I start the adding. And so you're kind of offsetting those so that the term is below and kind of in between the 2 up above it that it's the sum of. So that's Pascal's triangle. So the reason we care about Pascal's triangle is that we can use those numbers in the triangle as our coefficients when we raise a binomial to a power. So the first row, the 0 row, is useful because if I have x plus y to the 0 power, anything to the 0 power is 1. And my first row is just that 1. And a to the 0, b to the 0, that's just 1. If I have x plus y to the first power, I know that that's just x plus y. So 1x plus 1y. Those are the numbers in row 1. Because it's the first power, it's row 1. Then I'm going to show you x plus y squared. So obviously stuff is with a and b up above, but I think it's simpler to look at it this way and just in terms of what we already know. This would be 1x squared plus 2xy plus 1y squared. So that's the 1, 2, 1. And they add in that second term, b, they add in that's the 0 power at the beginning. So you have a squared b to the 0. So you can see how your powers for b are counting up and your powers for a are counting down. And we know anything to the 0 power is 1. So it's pretty much like just this part is not there, right? It's just a squared. And this is ab. And then this one over here, a to the 0 is just 1. So it would really just be b squared. So that's what that's showing us. And then just to continue this on and look at cubed, I would have 1x cubed. I don't know why I put equals or plus instead of equals. So we'd have equals 1x cubed. And there's no y at all there. And then we'd have 2x squared y. So my powers of x are counting down, 3 then 2. And then I would have, 3x squared y. And then I'd have 3xy squared. So that's the 1, 3, 3, and then I'll have 1y cubed. So I think on this one, by the time we get to the third power, we can really clearly see how my x's are counting down. X cubed, x squared, x to the first power, x to the 0 power, which is just a 1, and my y's are counting up. Y to the 0, y to the first, y squared, y to the third, and then these coefficients, the 1, 3, 3, 1, come from Pascal's triangle. So we're going to go ahead and use Pascal's triangle to expand a couple binomials and just practice with that. So if this is to the 6th power, I need to use row 6. So remember when we count those rows, they start with 0. One way that I can remember it is row 6 has a 6 in it. So my row 6 is 1, 6, 15, 20, 15, 6, 1. So the rows are always symmetrical. And just to flip back again, so this is that row we're looking at. This is row 6. So I'm just writing down those numbers. And then to go ahead and use this, I would have 1, because that's my coefficient. I'm going to have a to the 6th, b to the 0th power. And then plus, then my next coefficient is 6. And I'm counting down for a. So now I have a to the 5th, b to the 1st. So I'm counting down for my a exponents and up for my b exponents. And then next I have a 15, and now a is down to the 4th power, but b is squared. And then 20. And now I have a cubed, b cubed. And then it's 15. So my powers of a are still going down. 6, 5, 4, 3. This is going to be my a squared. and now b is going to count up and be fourth. And then I have 6ab to the fifth. And then my last term, which I'm going to have to squeeze onto the next line, would be a to the 0th. This one was first. Maybe I should have that one there for now. And then b to the 6th. So obviously there's some stuff to simplify here, right? Every time I have a 0 power, it's just equal to 1. So, and I don't really need that 1a to the 6th, b to the 0. So I have a to the 6th. And all of a sudden my marker's not writing. A to the 6th, there we go. Plus 6a to the 5th times just b, plus 15 a to the 4th b squared, plus 20 a cubed b cubed. I'm trying to write really small and fit it into one line, plus 15 a squared b to the 4th. Next line down, plus 6 ab to the 5th, and plus b to the 6th. So that's going to be our final kind of simplified answer. It would have been totally possible to have written it down this way. As I was going, we could have skipped those 1 coefficients, a 1 exponent we could leave off. Anytime we get a 0 power, we know we just don't have to write it down. But I think when you first see this initially, it's kind of good to see all the steps. So the second one we're going to look at is a little more complicated. We need row 5. So if I go back to row 5, my coefficients from Pascal's triangle, remember when we count, it's the 0 row and then 1, 2, 3, 4, 5th row. So it's the one with the 5 in it. So our coefficients are 1, 5, 10, 10, 5, and then 1. And so I'm going to have 1 times x to the 5th times that negative 2y to the 0. And then I have 5x to the 4th, negative 2y to the 1st. And then we have a 10x cubed, negative 2y squared. And then we have a 10x squared times negative 2y cubed. And then I'm going to have to go down here because I'm out of space. And now 5x to the 1st, negative 2y to the 4th. And then my last one is going to be 1x to the 0 times negative 2y to the 5th. And notice those negative 2y's, they are all going in parentheses. So because the 2 is part of that term, it has to get raised to that power also. I've got to have parentheses on it. So for my first term, I don't really need to write down my 1 coefficient, and this is just a 1, so I end up with x to the 5th. And then my second one, negative 2 to the 1st is going to give me a minus. So I'm not going to write down a plus sign. I'm going to go ahead and just write down a minus. And 2 to the 1st is 2. 2 times 5 is 10. So 10 x to the 4th y. Next one, the negative 2y is being squared. So now the whole thing's going to be a plus. And so the 2 squared is 4. I can multiply that by the 10. 4 times 10 would be 40. And now I have x cubed y squared. Odd power again for my y. So now I'm going to have a minus sign again. And this thing is not wanting to write. I don't know what's going on. Minus. There we go. On the next one, 2 cubed is 8. And 8 times 10 is 80. X squared y cubed. And then plus, because 2 to the 4th is 16 now, a positive 16 times 5 is another 80. Xy fourth. And then the last one, x to 0 is just a 1. It's going to be minus again, isn't it? So minus 2 to the 5th is 32, so 32y to the 5th. So sometimes we only want to know one term. And so something that's going to help us is to realize the connection between combinations, or that NCR thing that we were doing with our calculator, and then the coefficients in Pascal's triangle. So this is just another way of showing the 1, 1, 1, 1, 2, 1. So it turns out that like 5C2, for example, is going to be equivalent to that 1, 5, 10, 10, 5, 1. That this is going to be the same thing as 10. So it's kind of cool when you watch this, like the 5th row, we've got the 5th row 0 term, 5th row 1st term, 5th row 2nd term. So those actually match up with those combination numbers. And so it's a really cool way for us to quickly get a coefficient without trying to have Pascal's triangle right in front of us. So the tricky part on this is my rows start with a 0 term. And there are there's a 0th row also. So there's kind of some weird stuff with this that we have to be careful of. So basically, if I want to find the kth term of a binomial expansion of a plus b to the n power, I need to find r, and r is going to be k minus 1, because, for example, if I want the third term, really we start counting them with 0, 1, 2, so it's going to be something c2, and the term would be ncr, so r is that k minus 1. B is to the r power, so these two are going to match. And then my power on A and B, those are going to add to N. So we're going to go through and see what this exactly means. So number 3 is worded like it will be on the homework. Number 4 is worded the way it will be on your test. So I want to make that distinction here. So for number 3, we want to find the coefficient of our fourth term. So this means that my N equals 10. And I know that if I want my fourth term, k equals 4. And so my r equals 4 minus 1. So my r equals 3. So I need to find 10c3. That's going to be my coefficient. And then the a, oh, we're not even doing that though, right? We're only finding the coefficient. Okay, so we'll stop here. I was going to finish off the term. But 10c3 is going to be 120. So I would know the coefficient on that term is going to be 120. That is the sound of my dog in the background ripping up wrapping paper, and I have one problem to go, so I am not redoing this video. We're going to have to put up with the sound. Fifth term means that k equals 5, and so 5 minus 1 would mean our r is 4. And then this is 11, so n equals 11. And at this time, I'm trying to find the entire fifth term. So on that first one, we stopped. We only found our coefficient. That's the way it's going to be in the homework. On your test, I'm going to want you to find that entire term. So we start out with the coefficient, 11c4. And then I know that this will be 3x to a power and negative 4y to a power. Since this is fourth, this is going to be 4. And then these two powers are going to add to 11. And so the 3x will have to be to the 7th power. So these two powers, the 4s are always going to match. And then my x and my y, those exponents are going to add to make n. They're going to add to make 11. So 11c4 on my calculator is 330. And then 3x to the 7th is 2,187 x to the 7th. And then times negative 4 to the 4th would be a positive 256. And then we'll have y to the 4th. My last step is to multiply all my constants. So I have one giant coefficient, 184,757,760. And that's going to be x to the 7th, y to the 4th. So that would be our entire fifth term of that binomial expansion. So this is the end of our 10-5 notes.